Hello Cloud Pedagogians, and welcome to this lab where we are going to walk through the creation of our EKS cluster step by step. Elastic Kubernetes Service is a fully managed Kubernetes services from AWS. So in this lab, you will work with the AWS command line interface and as well console page. Using command line utilities like EKS CTL and kubectl to launch an EKS cluster. They provision a Kubernetes deployment and pod running instances of NGX and create a load balancer service to expose your application over the internet. I know it looks huge, but don't worry, we will take them step by step. So I hope you are very much interested in beginning with. So let's jump into our task. First, we are going to begin with creating our EKS workstation configuration in EC2. Then we will create an EKS cluster. After that, we will cross-verify the cluster creation in the AWS Management Console page. After that, we are going to deploy our application in the cluster. Finally, we are going to validate our cluster with the high availability feature. So start with the task 1, configure EKS workstation. And we are going to select EC2 to reach EC2 dashboard. Scroll down and click on Launch Instance. Enter an instance name and select AMI Amazon Linux 2023, and we are going to stick with the defaults as it is. I'm going to create a key pair and then download the key pair. In the network settings, make sure you have selected auto assign public IP because we want to able to connect to our EC2 instance. So just make sure that's set to enable. By default it is enabled, so don't worry. And then hit launch instance. And we can check on the status of our instance. It might just take a few moments to finish initializing, and then we should be good to go. So once your instance is up and running, we can configure our AWS credentials. We can connect to our EC2 instance, and you can just do it very easily using this connect button. And we are going to select EC2 instance connect and hit connect. And we have now got an interactive terminal session running on our EC2 instance. And this EC2 instance is going to be like an admin workstation for us. So we are going to be running all of our administrative commands from this EC2 instance. So the first thing we need to do is check the version of the AWS command line interface. So I'm just going to type AWS version and I'm going to find out where my current AWS CLI is installed, which I can say which AWS. So it's currently in user/bin/AWS. So you will be running version 2 of the AWS CLI. That's good. Now before we go any further, we are going to need to configure our command line interface. And this is why we need the access key and the secret key for our identity access management user. So hopefully you have created and saved those credentials somewhere. If not, just go to your AWS account in the Permissions tab, click Create Access section. For more details on how to create access and secret keys, check the link below in the description. And we can now run AWS Configure, and it's asking for the access key, so we just provide the access key for our user. And it is going to ask for secret access key. That's normally the longest string of characters. So just provide the secret access key. Default region name is going to be US East 1. And that's really important to get that right. And the output format is going to be JSON. So that is our AWS command line configured. And the next thing we are going to do is install kubectl. So first of all, we are going to download the binary. We are then going to add execute permissions to the binary. And we are going to copy the binary to a directory in our path. And don't worry too much about this command. It's just basically puts the binary where you need it so that you can access it every time you try to unuse it. And it's something that you only have to do one time. So now we can check whether that has been installed correctly by just running this command, kubectl version short client. And that's look pretty good to me. So the last thing we need to do at this stage is install EKS CTL. So once again we are going to download the binary and it's downloaded to /tmp directory. So we are going to move it to user/bin. And that should be everything that we need to do for EKS CTL, and we should be able to run EKS CTL version. And there we are, it has successfully been installed. And EKS STL is a really simple tool. It's a tool that enables you to create, update and get information about your EKS cluster. Good job, we have created our EC2 instance and installed our command line tools that are required for the EKS. In the next task, we are going to create EKS cluster. In this task, we are going to use EKS CTL to create our EKS cluster. I am going to run this command to create my cluster. So this command is going to create a cluster called cpdev EKS cluster. It's going to use Kubernetes version 1.+. It's going to use Kubernetes version 1.16. The region is going to be US East A, and we are going to create a group of managed worker nodes. And our node group name is going to be standard workers. The type is going to be T3 medium. That's the type of EC2 instance that will be our worker nodes. We are going to launch 4 worker nodes with an auto scaling group with a minimum of 2 and a maximum of 4. So that is our command, and it is going to do a lot for us behind the scenes. So it's going to create all this stuff using CloudFormation. It will take 10 to 15 minutes since it's provisioning the control plane and worker nodes, attaching the worker nodes to the control plane and creating the VPC, security group and auto scaling groups. So let's wait for some time and check the status. Good work, you have created EKS clusters successfully. In the next task, we are going to verify this in console of AWS management. Let's take a look at the AWS console and we can actually follow what's going on here in CloudFormation. So here I am in the console and I'm going to head to services, and you will find CloudFormation under management and governance. So click CloudFormation, and here is our CloudFormation stack in progress. So if you click on our stack, you can head to events and you will see everything that CloudFormation is creating for you. So it started off creating security groups for the control plane, creating route tables, subnets. So it's creating all of the networking. It's created a VPC for us, internet gateway and identity access management roles as well. So all of this is going to on this background, and we're just going to have to wait until all of our CloudFormation jobs have completed. And as I said, it's going to be about 15 minutes at least. Sometimes it may fail if they don't have enough capacity in the availability zone to provision your resources. If that does ever happens to you, all you need to do is wait for the CloudFormation rollback to complete, and then you can just run the command again. So here we are a few minutes later. So we have got our 2 stacks here, one to create the control plane and one to create our nodes as well. And that's why it takes so long. Now if you go to services and head down to containers and head to Elastic Kubernetes service, we can go in and see our cluster. And there it is. So select your cluster, and if we head to compute, we will find our group of nodes. Instance type is T3 medium and they are all in active state. So if you head back to the network section, so these are all the subnets that is created for us. Now the control plane itself we can't log into, and we are going to communicate with the control plane using kubectl. So let's now head back to EC2. You will see that you have now got 5 instances. So these 4 are our worker nodes and this one is our admin workstation. So let's connect back to our admin workstation and check with command. I'm going to run EKS get cluster. So there is our cluster and region, and this command just configures kubectl so that it can connect to our Amazon EKS cluster. Good job. At this stage, we have just created our EKS cluster. In the next task, we are going to deploy our web server. Next thing is, and we are now ready to configure our NGINX. So we are going to create our load balancer service as well as our deployment of our 4 pods and our containers as well. So let's continue that. First, we are going to download the YAML files from GitHub. So if you see here, we have got 2 YAML files and we are going to use these YAML files to configure our deployment and our service. So first of all, let's take a quick look at our deployment file. So here is the name of our deployment and we are giving it a label. We are creating a replica set of 4. So there is going to be 4 instances. So we are going to have 4 pods each running a container in a pod. And down here at the bottom we are specifying the Docker image and it's going to be the standard nginx image from Docker Hub. So now let's take a look at the configuration for our service. We are going to use the same label. The type is going to be load balancer and the port that we connect on is going to be 80. It's best practice that we actually create the service first. We are going to create the load balancer before we create the corresponding backend workloads. So we create the load balancer before we create the pods and deployments, etc. Because when Kubernetes starts a container, it actually provides some environment variables pointing to all of the services which were running when the container was started. So any service that a pod wants to access should really be created before you create the pod itself. So for that reason, we are going to create the service first, and all we do to create the service is really simple. It's just type kubectl apply file option with our file name and hit enter. There we go. That's our service created. Now we can type kubectl get service. And there is our service. So it's actually creating an AWS load balancer. It's better copy the external DNS hostname of the load balancer and pasting it into a text file as we will need it in a minute. So now we are ready to configure our deployment and our pods and our web server. Let's run kubectl apply for our deployment file to apply the configuration for our deployment. Next we can run kubectl get deployment. So we got 4 instances running. If we run get pod, we can see our 4 pods. And if we run get rs, we can see that we have got 4 out of 4 running. And if we want kubectl get node as well, we can see our 4 EC2 instances. Next thing is, how do we access our application? Well, we access our application using our load balancer because it's the load balancer which exposes our application to the internet. So we can just run curl and then we are going to copy the DNS name of our load balancer, paste it down here and hit enter. So if it is all running correctly, it will display this default splash screen for nginx. And this is what it looks like. And we can also test it, of course, using our browser window. So let's do that as well. In a new browser tab, navigate the same paste the name of your load balancer. We should then see the same nginx web page. So we are accessing the nginx application. It's running in a container on a deployment on our EKS cluster. Good work. At this stage, we have built everything. We have built our cluster, control plane, our worker nodes. We have got a deployment setup and we have got all of our pods running with their containers as well. In the next task, we are going to check EKS high availability feature. So in this task, I want to check if our cluster is really working properly and that our high availability features are really working as expected. So I'm going to head to the console and I'm going to start shutting down at some of my worker nodes. So here I'm in the console and I'm going to head to EC2, go to running instances, and these are my 4 worker nodes. So I'm going to select all 4 and I'm going to stop them all. And if I hit refresh, you will see that all 4 instances are stopping. So while those are all stopping, I'm going to connect to my admin workstation. And the first thing we are going to run is kubectl get node. And you should see that all your nodes are in a not ready state. So let's run kubectl get pod. And we can see that some of our pods are terminating. We have got few that's still running and a couple in a pending state as well. So as our instances have been shutting down, it's been trying to restart those pods. So let's just check our nodes again. And we can now see there is actually a new node and we can identify the node by its age. So it's only few seconds old. So this is a new node that EKS has provisioned for us. And this is just for the first one. So this is the first of 4, and if you wait for a few more minutes, you should see 4 new nodes. So let's check again. So our first node is actually ready now, and it didn't take a very long time. So some of our few nodes are actually ready now, and it didn't take very long. Let's take a look at our pods and see if any of our pods is in a ready state yet. And yes, it's look like we have got a couple of pods running as well. So even though we shut down our host, EKS has provisioned new hosts for us. It started up our pods, and then the last thing we can do is to check everything is really working and that our application is actually up and running. Let's run kubectl get service. Then we can run curl command and grab the name of our load balancer. And there is our little welcome screen from our load balancer. And of course, you can also paste the URL of the load balancer into a new browser tab, and that will also display the welcome screen. So our application is definitely backing up and running. Also, you can see that we have built a pretty complex clustered environment using just a few commands. And that's all about the configuration. And if you have done any of this in your own AWS account, when you're done using an Amazon EKS cluster, you should delete the resources associated with it so that you don't incur any unnecessary costs. You can simply type EKS kubectl delete cluster and the name of your cluster, and that will go in and delete all of the EKS elements. And you will also need to go to console and delete your EC2 instances. Congratulations, you have launched an EKS cluster with 4 worker nodes in the US East 1 region, then created a deployment and a pod running container instances using the public nginx image. Then we have exposed the application to the internet by adding a load balancer service. I know it's pretty long, but if you have any questions, please let me know in the comments. Otherwise, see you again and have a wonderful time with learning.